Hello and welcome to this episode of Night Sky News for June 2025 with me, astrophysicist Dr. Becky Smethurst. This is a show where we chat about what you should look out for in the night sky in the next few weeks, and then we chat about what's been happening in space news in the past few weeks. In this episode, we're chatting about the new studies that have come out using JWST data of the infamous exoplanet K2-18b, now claiming there's no evidence for dimethyl sulfide in its atmosphere, unlike the claims from a recent study that made headlines. Plus, we've got more detail on those proposed budget cuts to NASA and the National Science Foundation, along with the discovery of a new most distant galaxy known using JWST. There's chapter markers down here if you want to skip ahead to any of those specific news stories, plus any scientific research papers I mention are all going to be linked in the description down below, free to read. So without any further ado, let's kick things off and start by looking up. Now, June can only mean one thing in the astronomy world, and that is the solstice, which this year is on the 21st of June. Now, if you're in the southern hemisphere, that marks the shortest day and the start of winter for you, meaning there is ample stargazing opportunities, including the best view of the Milky Way right now. But in the northern hemisphere, it marks the start of summer with the longest day, which means that for a lot of us, the sky just isn't getting dark enough at the moment for us to be able to see that many stars, because the sun is only dropping just a few degrees below the horizon after sunset before rising again. One thing to notice though, as you're sat outside enjoying those long warm evenings, is that the sun will be setting the furthest round to the northwest that it gets, and then rising again the furthest round it gets to the northeast. So if you have a clear horizon and you've been watching the sun set over the past few months or so and noticed it moving from west through to northwest, the solstice is where it will stop and then start moving back around towards the west again. Or maybe you're an early bird and you've been watching the sunrise steadily move round to the northeast. If that's the case, do not stop watching on the solstice, because the day after, on the morning of the 22nd, you've got a pairing of the crescent moon, aka my beloved Toenail moon, with the planet Venus in the east just before sunrise. It should be a spectacular sight wherever you are in the world, at least if the sun actually drops below the horizon for you at the minute, just because Venus is so bright in the night sky. It's the brightest thing after the moon, so if you're up early enough to see this, see if you can spot it. If you're not a morning person though, and you want to stick to stargazing in the evenings, then your best bet for this month is the 25th of June, which is the night of the new moon, so the sky will be the darkest it gets. So if you are in the southern hemisphere and want to try and spot the Milky Way like we chatted about in last month's Night Sky News, that will be the best time to try and do it. Also, the further south you are, the better chance you have of spotting the planet Mercury, which, because of how close to the sun it is, it means it's very difficult to spot because it's not around for very long after the sun sets. But it's reaching what's known as its greatest eastern elongation on the 4th of July. So the furthest it gets from the sun from our perspective here on Earth. That means it'll be at its highest in the sky just after sunset and stick around for just that little bit longer. You will need a very clear horizon for this though. So a western coastline, for example, that looks out over the sea is probably going to be the best place to try and spot Mercury. In particular, on the 26th of June, if you're in the Americas, then the timing is just going to be right for you to be able to see a great lineup of Mercury, tiny sliver of a toenail moon again, and then the twin stars, the two stars in Gemini, Castor and Pollux. So if you've never spotted Mercury before, this could be your moment, right? Because you've just got one big giant cosmic signpost telling you where to look. If you missed that though, don't worry, there are still sites you can look out for this month. For example, on the 29th of June, there's going to be a very close pairing of Mars with the moon. For most of us, they'll come about within 1/6 of a degree of each other on the sky, so just 1/3 of the diameter of the moon. But if you are one of the lucky few on the northwest tip of South America, you will even have the right alignment to see the moon pass in front of Mars at around about 9 p.m. local time. Either way, break out your binoculars, because this is going to give a great view of both the moon and Mars in the same field of view of your binoculars. Remember, all we see of Mars is just a slight reddish dot. There's no detail like with the gas giants of Jupiter or Saturn, sadly, just because it is so much smaller at around about half the size of the Earth. But now it is time to turn our attention to the space news stories of the past month, because there have been some big ones. Like, did you see this one about the discovery of a new unexplained object pulsing in radio and X-rays in a way that we've never seen before? Now, stories like this on objects giving out weird radio pulses often make it to strange corners of the internet, just because, everyone wants it to be contact with aliens. So when you see a headline like this, how do you know that what you're reading is like a legitimate story that's based on actual scientific research findings? Well, that's where Ground News comes in, the sponsor I've been working with for over a year now. With Ground News, I can see straight away that 109 different news sources covered this story, with 99% of those sources having high factuality ratings. So with a few quick glances, I immediately know that this story is genuine. But then also, I can easily compare headlines from different news sources. I can see that Time magazine went with a classic, right? Scientists are stumped by mysterious pulsing star, whereas The Conversation had X-rays have revealed a mysterious cosmic object never before seen in our galaxy. And compare that to the extra detail given by Forbes' headline, 44-minute pulse from mystery object baffles scientists. What to know? I also particularly love Ground News' bias comparison tool, which gives me insights into how media outlets from each side of the political spectrum covered the story and which aspects they focused on. It's data-driven tools like this from Ground News that make staying up to date with the news so much easier. Like their blind spot feed, which shows you stories that had little to no reporting on either side of the political spectrum. So if you head to the link in the video description down below, ground.news/Dr. Becky, or scan the QR code on screen, you'll get 40% off their Vantage plan, which gives you unlimited access to all of their features. It comes out to around about $5 a month. And those subscriptions help keep Ground News ad-free and therefore free of any of the bias that comes with paid advertising. So a big thanks to Ground News for sponsoring this video. And now let's come back down to earth and chat about what's been happening in space news in the past month. All right, first up, let's talk about the now infamous exoplanet K2-18b and the ever-growing doubt in the scientific community that we have actually detected a sign of life on K2-18b. So, K2-18b is a planet that orbits another star in our galaxy of stars, the Milky Way. It's about 124 light years away from Earth, and it orbits a red dwarf star, which is much smaller and cooler than our sun. K2-18b takes just 33 days to make one orbit of its star, so it orbits much closer in than the Earth does around the sun. But because the star is cooler, it still sits in what's known as the habitable zone around its star, where you're getting the right amount of light and heat from a star so that any planet there would be not too hot and not too cold for life, at least as we know it, to exist there. Now, back in 2023, Medusa and collaborators released this paper claiming a tentative detection of a molecule known as dimethyl sulfide in its atmosphere. That's a molecule that is associated with life, so biochemistry here on Earth, so it's always thought to be a good one to look for in other planets' atmospheres in the search for life. It was tentative though because the data they had from the James Webb Space Telescope, JWST, just wasn't good enough to make a strong claim. But then, this year, in 2025, Medusa and collaborators published another paper, this time analysing different JWST data of K2-18b at a longer wavelength, so redder light, and once again claimed a detection of dimethyl sulfide and dimethyl disulfide in the atmosphere of K2-18b. Now, the way they do this, detecting these possible biosignatures or biomarkers that life might be present in that planet's atmosphere, is they wait for the planet to pass in front of its star from our perspective here on Earth. Then they can see the impact that the atmosphere has on the background starlight. So each molecule likes to absorb specific wavelengths or energies of light. And so by finding those specific signatures of each molecule, we know a molecule is there. Sounds simple when you explain it like that, but in practice, it is very difficult. A, because that data is very, very noisy. B, because there are just so many molecules that you could look for, and C, because all of the signatures from those molecules all overlap. Hence why all of these claim detections have been tentative. They haven't passed like the threshold that we need in physics to claim that we have strong evidence for something. As an aside to that, even if it turns out there is dimethyl sulfide in the atmosphere of this planet, that doesn't necessarily point directly towards life existing on that planet, because dimethyl sulfide has also been found on Mars and on comets and in the gas between stars. Just because the only way that it's naturally produced here on Earth is through life, through biochemistry, doesn't mean there isn't some unknown known as yet to us chemistry that also produces dimethyl sulfide. I went into all of this in more detail in my previous videos on this if you want a bit of a deep dive. For this month, I want to talk about 2 papers that have been published. One from Milky and collaborators and one from Wellbanks and collaborators that both question that detection of dimethyl sulfide in the atmosphere of K2-18b. So let's start with the one from Milky and collaborators, which reanalyzes all of the JWST data at all of the wavelengths together for the first time. So they took the raw data fresh off the telescope and reanalyzed it themselves with a bunch of different reduction codes to see if that was having an impact on the results, and tested whether atmosphere models with ethane rather than dimethyl sulfide could fit the data better. Ethane has a similar chemical structure to dimethyl sulfide, and so it can have a very similar impact on the light, which means you can confuse it for dimethyl sulfide. And they find that with the data we currently have from JWST, they can't tell the difference between the 2 models. The dimethyl sulfide model and the ethane model seem to be equally as likely as each other, and they say that to have like strong enough evidence to actually claim that the dimethyl sulfide model is better than the ethane model, you would need so much more signal versus the noise in your data that you would need to observe 25 more transits of the planet in front of its star. Basically, they're saying the data we have at the minute is just not good enough, right? You don't have a strong enough signal compared to the amount of noise that you have, and the fluctuations that you're looking at for all these individual molecules are not only blending together, but they're down in the parts per million. And in fact, Milky and collaborators state that any marginal preferences are the result of limiting the number of molecules considered in the model. An idea which was also explored by Wellbank and collaborators this month. They focus on this idea of the sheer number of possible molecules that you could even consider, which then give you a vast number of different combinations you could then have to make up a planet's atmosphere, all of which end up being degenerate with each other, i.e. meaning that you can confuse one for the other. What this means is that if you're comparing models of the atmosphere that take into account fewer molecules and remove just one molecule from your model, you can get a higher detection significance for that molecule's existence in the atmosphere that's actually artificially inflated. And again, they show that if you consider other possible molecules besides dimethyl sulfide, then you can get stronger evidence for something like propane in the atmosphere of K2-18b compared to dimethyl sulfide. But really they argue that there's just so many different models with all different mixes of molecules that give you a similar kind of like evidence support to what's been claimed for dimethyl sulfide, that they argue that the threshold for claiming a detection in the first place needs to be higher and not based on model comparisons alone. And of course, higher signal compared to the noise in your observations and a wider wavelength coverage to help with all of these different confusion of these molecules that maybe you can split out by looking at a different part of the spectrum of light will also help as well. So yeah, there's a lot of doubt on that claimed detection of dimethyl sulfide, just like there was in the aftermath of the first claim back in 2023, which again I covered on this channel at the time. And it's likely there's going to be a lot more research groups that reanalyze this data in the coming months and years to try and get to the bottom of this. I particularly loved how Wellbanks and collaborators put this. These aren't failures, but signs of a community moving towards deeper, more reliable inference of these biomarkers, so that if we do find a sign of life in an exoplanet's atmosphere, we can be sure of that detection. And if you're thinking, but what if it's not life as we know it, and it's completely different to life here on Earth, and we're looking for all of the wrong things, then you're gonna love the video I made on that this month, which I will link below if you want to check it out. Of course, all of that future work with JWST relies on NASA continuing to fund JWST, which thankfully this month we did have confirmation of following the release of NASA's budget justification by the White House. So a quick recap for those of you who missed last month's Night Sky News. The current US government have proposed a 24% cut to NASA's budget, with the majority of those cuts hitting astrophysics and earth science, and money instead being put into space exploration with the goal of putting humans on Mars. Now, rumours of these cuts have been circling for a few months now, but we had confirmation of them with last month's skinny budget that was published that was just kind of like a, hey, this is what we want to do. But now there is a 462-page budget justification document that's been published for us all to pore over, and honestly shed a tear as we read it for all of the science that now won't happen if this this budget gets passed. Let's start with the top level numbers. So it's an overall proposed budget of $18.8 billion, down from $24.8 billion in 2024. That is your 24% drop in the budget right there. That's the top line. And just to say, we're comparing to 2024 numbers here because they've actually, made it all the way through Congress and got passed and approved. The 2025 ones are still going through that process now, so aren't final just yet. But the big headlines here is that you've got a 26% cut to the International Space Station budget, a 52% cut to the Earth science budget, a 31% cut to the planetary science budget, and brace yourself, a 66% cut to the astrophysics budget. So what does that mean in practice? Let's start with the planetary science side of things. Thankfully, the planetary defense budget has been increased. So that's the programs that track near-Earth objects and hazardous asteroids so that we can be prepared if there is anything that's going to be a danger to Earth. But as expected, the two big upcoming missions to Venus, Da Vinci and Veritas, have had their funding completely cut, so they're cancelled. Which means I guess we're going to have to wait longer to find out if that detection of phosphine in the atmosphere of Venus, phosphine being another biosignature, a biomarker of life, we'll have to wait longer to find out if that actually was life or not. Similarly, the extensions to New Horizons, which was the first probe to fly past Pluto, and OSIRIS-REx, which collected a sample from the asteroid Bennu. Both of those extensions have been cut. These are both missions that, achieved their main science goals, like what they were launched for. But then, they're up in space anyways, they might as well be useful, right? So a quick sort of change to the thrust systems puts them on a brand new trajectory so that they're able to point themselves at a new object for them to explore. Great, they're going to fly past those objects. Thing is, though, there's now no funding to support, a missions team or a science team or use NASA's Deep Space Network to actually detect the signals that they will actually send out and download the data that they collected back to Earth. They'll just fly past both of their objects and no one will know what they found. Similarly, Juno has been completely cut. It's still in orbit around Jupiter, sending back useful data, but now there's no support for the mission team or the science team to do any more analysis. And as expected, the Mars sample return mission has been cancelled. This was the project to return the rock samples that have been collected by the Perseverance rover back to Earth with another lander, so we can test them in a lab here on Earth for signs of life. Instead, the budget claims this will be done by humans sent to Mars in a similar time frame, but that's a whole other can of worms. See my video from last week for more on that. Thankfully, Dragonfly escaped all of the cuts. It's had its budget boosted by 37%. This is the mission to send a drone to explore Saturn's moon Titan and assess if it's habitable to life, either as we know it or that we don't know it. The boost in budget is in line with the agreed on budget when the project started development, so perhaps all those other cuts are to fund the budget that's already been promised to Dragonfly, but that doesn't make them hurt any less, and that's just planetary science. We haven't even got to the 66% cut to the astrophysics budget yet. So let's start with the major observatories. The Hubble Space Telescope gets a 9% budget cut, and JWST a 25% budget cut. So those budgets support the day-to-day operations of the telescope and actually taking the data, but they also fund the research on that data as well. The justification for these cuts is that the operations will just be made more efficient, but with no idea yet how to do that. NASA have just been instructed to assess the options for how to do this. To me, though, that just reads as job losses and more work without compensation for the people who do keep their jobs. The biggest cuts, though, come to the physics of the cosmos subsection, which had a 99.7% budget cut. So the Gamma Ray Space Telescope Fermi completely cut. So is the X-ray telescope Chandra that we all campaigned to save last year. And all US contributions to a few European Space Agency missions, including LISA, the gravitational wave detector in space, and the recently launched Euclid telescope, raising the questions of whether researchers at US institutions will even have access to that data anymore, which they did in some cases before, it was eventually made public further down the line. On the good news side, the Nancy Grace Roman telescope thankfully survived The cuts, albeit with a 62% budget cut, again explained away as cost-saving strategies and schedule optimization opportunities. Then there's the Habitable Worlds Observatory, which I've talked about on this channel before. It's NASA's next generation telescope that has kept some funding for the development of new technologies it will need to take a direct image of an Earth-like planet like is in the plan, but it has an 81% budget cut to do that. And then a big surprise was a complete budget cut to the operation of the Keck telescopes on Mauna Kea, which have been a cornerstone of US astronomy for decades and are still operational. This was the telescope that was used to prove there was a supermassive black hole at the center of our galaxy, the Milky Way. And speaking of telescopes, it's not just NASA that's been hit by budget cuts, it's the National Science Foundation too. And with it, a complete axing of the 30-meter telescope, the TMT, that was planned for construction on Mauna Kea. Now, this one was not that much of a surprise. We knew that NSF had been given this ultimatum already to choose between funding the TMT or the Giant Magellan Telescope, the GMT. If you remember, I spoke about this in a previous Night Sky News episode. And yes, it made sense logically to cut the TMT over the GMT because construction has been halted on it for years now because of protests by locals on the Big Island. The problem is that scientifically speaking, the GMT is less useful to us where it is in the Southern Hemisphere. The European Southern Observatory are already well ahead in their build of the ELT, the extremely large telescope down in Chile. And ideally, for full sky coverage, we would have had another similarly sized telescope in the Northern Hemisphere, which is what TMT was supposed to be, but now we just have GMT also in Chile. Another surprise was the 100% cut in the budget for astronomy and astrophysics postdoctoral fellowships. That one hit really hard. That's the stage of my career that I'm in now, postdoctoral, like post-PhD, but you don't have like a permanent job at a university yet. So in the UK, that's like a professorship. In the US, it's called tenure, right? You're just in this weird part of life where you've only got 2 or 3 year postdoctoral fellowship contracts that you constantly have to keep reapplying for, like a whole brand new job, sometimes changing institutions and countries all around the world. With all of that NSF funding gone and a load of other NASA research funding cut, there's now way more competition for all of the surviving jobs that are still funded. And for anybody who wants to go into astronomy and astrophysics in the next couple of years, that is really concerning. There just won't be as many jobs in that stage after your PhD before you get that permanent position. Seeing all of this, I don't think people are exaggerating when they say it's an extinction level event for space science and astrophysics research in the US. And it's one that's going to have huge ripple effects around the global astronomy and astrophysics community as well. We just have to remind ourselves this is still a proposed budget. It still has to go on the long road through Congress. If you're in the US and you don't want to see NASA's budget cut in this way, you can make your voice heard by writing to your member of Congress. The Planetary Society have collected a load of resources to help you do that, which I'll link below. And they're spearheading a petition which can be signed by anyone, wherever you are in the world, which I'll also link below. So if you do anything after watching this video, go sign that petition. All right, let's have a science cleanser after that, shall we? We have a new record holder for the most distant galaxy, known as MOM-Z14, which was discovered by Naidu and collaborators with JWST. Now, as usual for this field of finding the most distant galaxies, this was found using a technique known as Lyman break. So JWST takes the light from a galaxy and splits it into its rainbow of colors so that we get a trace of how much light each color or wavelength of light we receive. And what we look for in these spectra are what's known as breaks, sudden drop-offs in the amount of light received, which is caused by hydrogen gas in between Earth and this distant galaxy. So as the light passes through clouds of hydrogen gas in the universe, the hydrogen atoms like to steal away a very specific color or wavelength of light, but because as the light travels, space is also expanding, the light gets stretched to a longer and longer wavelength, and that initial missing bit of light appears at a longer wavelength. But then the next gas cloud the light passes through steals some more light, and so on until you have a lot of the light stolen away by all those many clouds of hydrogen gas at those shorter wavelengths. The handy thing is, if you can pinpoint where that drop-off occurs, then you know at what point in the universe's history did the first, absorption by a hydrogen cloud of gas actually happen, and therefore you know how long the light has been traveling through the universe for, and therefore how far away that galaxy was when the light was emitted. So here's the spectrum for the new record holder. You can see that drop-off happens at just past 1.8 microns wavelength of light, giving you a redshift stretch factor of 14.44. For context, the previous record holder had a redshift factor of 14.32. But what it means is that the light that we now detect from this galaxy MOM-Z14 was emitted when the universe was just 280 million years old. And it also means that the video that I made last year, which covered every single galaxy that has ever held the title of the most distant galaxy known, is now out of date. And that is science progress for you. All right, that's it for Night Sky News for this month. As always, if you spot any space news stories that you want me to explain in a future Night Sky News episode, or if you snap any pictures of the night sky and you want to share them with me, then tag me over on social media because I would always love to see them. But until next time, everybody, happy stargazing. Here we are again, somehow halfway through the year. What is happening to time? In the southern hemisphere, in the southern hemisphere, I can't do a Kiwi accent, but that was the trip up into it. There is an ice cream man outside that's just plinkly plonkily playing his tune, so I'm just giving him a second. It's 5 o'clock. The motorbike parade is out. Fusion of different. And quite honestly, just shed a tear for all. Did you hear that? That was the wind. Maybe that was the universe telling me not to cry over this, because it hopefully won't happen. Still making their way through Converse. First probe to fly past which was the first probe to fly past Pluto. That was just planetary science. We haven't even got to the 60 cent. Wish it was only 60 cents. In galaxies, this was found using a technique. Jacinda Ardern's back again. Albeit